This video is going to be all about the different classes of antibodies. So we've already talked about the structure of an antibody, which is this Y shape, and some antibodies remain alone. Okay, they work by themselves, and so we say that is the monomer, that little Y shape. However, some antibodies can actually link together, as you see below, and form a dimer, which means there's two antibodies, or even a pentamer, where there are 5 antibodies. Now remember, each antibody has 2 paratopes, okay? So with a monomer, there are only 2 paratopes because it's one antibody. With a dimer, okay, we have 2 antibodies, but each one has 2 paratopes. So how many paratopes does the dimer have? 4, right? We're gonna have 1, 2, 3, 4. If we get down to this pentamer, how many paratopes do we have? 10. 2 paratopes per antibody times the 5 antibodies. Okay? Which antibody structure would be most efficient at binding antigen? Well, that would be this pentamer, right? It can bind 10 different epitopes. Okay, maybe some of those epitopes are on a single pathogen. Maybe it's rounding up 4 different pathogens by binding to their epitopes. Okay, so the pentamer structure is most efficient because it can actually wrangle up multiple pathogens at one time. So let's talk about the different classes of antibodies. I will always use the term classes, though in future classes that you have, they may call them isotopes. So there are 5 classes of antibodies. Class or type G, A, M, E, and D. Gamed is how I remember it. And so they're called IgG, right? Because an antibody is a type of immunoglobulin protein. And so they just put Ig there instead of writing out antibody A, right? They put IgA for immunoglobulin A, but no, it's the same thing, class A antibodies. So this is a different chart than what's in your PowerPoint because I just want to have some numbers to show you to explain why, kind of the reasoning behind the points made in your PowerPoint. Now, of course, do not memorize these numbers, okay? But I want you to think about why these numbers are important. Okay, so let's go ahead and just start with G because it's first in this particular table. So if you look at IgG, it is a monomer, okay? It is a single antibody, so 2 paratopes. And if you were to sit here and study this table, you would notice that what's unusual are a couple of things. The third row, percentage of total antibody in the serum is 80%, right? Compared to 13, 6, 1, and 0.02. So what that means is there's a lot of IgG in the body. And that's probably related to row 4, the average half-life, okay, in days. Notice IgG is present for a lot longer than the other classes of antibodies. And this is because it is the only antibody that can cross the placenta. So this is what offers a fetus some sort of protection, right? It has not been outside of the womb exposed to all the pathogens of the world, right? So it needs some sort of protection. And so IgG is able to cross the placenta and offer a fetus some protection. But eventually that fetus will be born, right? And the newborn baby will be exposed to minimal things right off the bat, but it still needs an immune system, right? And so that is why the half-life of IgG is so large. It's going to offer that newborn baby some extra protection because it lasts in the body for a while, okay? And so IgG is going to have a role in like opsonization and neutralizing toxins and helping to initiate the complement system. All right, next up is IgA. And IgA is next in the percent of total antibody in the serum, also for the half-life in days. And it cannot cross the placenta, okay, but notice where what its big function is in that last row. It is a secretory antibody. That means it can be secreted through things like breast milk, okay? And so IgG and IgA are going to be what helps protect newborns and infants. Okay, and so how I remember this, because you will be tested on, what these antibodies do, is when people do baby talk, right? It's goo goo, ga ga, ga, ga. G is going to protect the fetus and a newborn, whereas A is going to protect the newborn via breast milk. All right, next up, look at M. So I think of M as mega. Okay, some people think of M as macro. Same thing, it's large. So IgM is the pentamer. And so notice in its function, produced at first response to antigen, right? It can go and round up a ton of antigen. So when we first detect that there's a problem, we want IgM on the prowl, right? Because it can round things up much quicker. IgD, we don't know a whole lot about it, so I'm not going to quiz or test you on IgD, but it exists. IgE, however, it is the antibody of allergies, okay? Because notice what it binds to. Mast cells and basophils, which are both cells that release histamine, okay? And so we don't have a whole lot of these in the body, but when you do like allergy shots and stuff, it's you're trying to kind of boost your IgEs. All right, that is going to be the end of our antibody chat. Again, please don't go memorizing this table or anything. I just wanted you to understand why the function of each class of antibody is what it is. All right, let me know if you have any questions.